Elon Musk, good to have you with us.
Thanks for having me.
So there's a clear answer to this question, and then there's the existential answer to this question. What are you guys building out there?
We build rockets and spacecraft.
Yeah, now give me the existential answer.
Well, what we are aspiring to do is to help make humanity a true spacefaring civilization and ultimately become a multi-planet species.
This is going to sound
Is that
pejorative.
existential enough for you?
That's quite existential. I like that. But here's the thing. You're doing it on the cheap. I mean, that's, there's an award out there in the lobby that says, Elon Musk, you get the award for economic spaceflight.
Yes. Well, the fundamental problem with rockets is that they are far too expensive. And so that's the thing that has to be improved dramatically by ultimately, I think, at least a factor of 100.
That's a pretty good, chunk of change you're taking out of the cost of this thing.
Yes, absolutely.
How do you do that?
In order to achieve that level of improvement, the great breakthrough that is needed is a fully and rapidly reusable rocket. No one has ever succeeded in building this. In fact, no one has ever succeeded in building a fully reusable rocket of any kind, at least that's capable of getting to orbit. This is, whether SpaceX does this or some other organization, I think it will be one of the most important inventions in the history of humanity, or life itself, really, because it is the pivotal thing that is needed for life to extend beyond Earth permanently.
Key word there is fully reusable, right? Because people look at the space shuttle and they say, oh, you can reuse that.
Yes, in fact, I'd go a little further than that and say it has to be fully and rapidly reusable. There are two problems with the space shuttle. It is not fully reusable, and it is not rapidly reusable, even the bits that are reusable. But if you think of something like an airplane is fully and rapidly reusable. Or if you consider what did the Wright brothers invent? They actually did not invent powered flight. They did not invent controlled flight. They invented controlled powered flight. That was important.
What role then does NASA have? Because NASA has not been able to master that reusable and rapidly reusable part.
I think NASA has an important role, and SpaceX would not be where it is today without the help of NASA. A lot of the technology that we've developed is really built upon what NASA has developed, and NASA has been our single largest and most important customer. So we have a huge debt of gratitude that we owe NASA. And I think NASA will continue to be an important part of the future. But I also think that a company like SpaceX is important to bring sort of an entrepreneurial, fast pace of technology, sort of a Silicon Valley approach to things, and to pair that up with the traditional sort of approach to space in order to achieve substantial breakthroughs.
You look at NASA, though, and it's one of the shining stars of American technology for the past 50 years, right? John Kennedy, we're going to the moon, the whole deal. You come along and say, I can do it cheaper, faster, and I would imagine you would also say better. Traditional supporters of NASA say, wait a minute, this is the death of an American icon. How do you respond?
I think that's really inaccurate. What it really, I'd say, is it's really there's an evolution that's necessary. And that evolution involves a public-private partnership. And there are lots of really smart, good people at NASA, but they are somewhat tied up in the constraints of a government organization. In fact, many of our best people at SpaceX came from NASA. So, there are limits on what you can do as a government organization and a very large one. And those limitations, however, can be overcome, I think, by partnering with a fast-moving entrepreneurial company like SpaceX. And then I'm sure there will be other companies as well. So I think that is what yields the best result for the American people.
Should space travel be fully privatized, space exploration?
Well, I wouldn't say it should be fully privatized.
Mostly?
Yes, mostly privatized. Like the rest of the economy, we're sort of, I think, around 40% of the economy is government, if you consider all levels of government. And probably that's about the right percentage for space as well. And in fact, if you look at our launch manifest is about 40% government, roughly speaking. We've got over 30 of Falcon 9 missions on contract, and of those, 13 are from NASA. But the others are actually we now have, I think, 20 missions that are non-NASA. So it's actually NASA's a little less than 40% of our missions. And if you were making pencils, 40% of your business would be with the government. So our percentage is not out of the ordinary with other businesses.
So space travel is, and space exploration and space flight in general, is a dangerous occupation. And I'm sure you remember from your history and your study of this, all those old footage of the Mercury rockets and the first experiments, and they go up off the launching pad and they collapse back down. That hasn't happened to you yet. What happens when it does?
Well, we certainly will do everything we possibly can to avoid any loss of life, but in any dangerous endeavor, that is a risk that has to be considered and likely will occur, as it does in any mode of transport. I guess we'll just really do our absolute best to ensure that it doesn't happen, and if it does, understand very carefully what went wrong and take corrective action.
Here's why I ask.
Yeah.
When the Mercury rockets blew up and all those early test flights blew up, it wasn't like that rocket's backers were going to walk away. The government was never going to walk away. If something happens on a SpaceX flight, do you worry about your backers saying, you know what, Elon, I'm sorry, I thought I was in, but I can't do this when we got rockets blown up on the pad?
Well, yes, I am the main backer of SpaceX, so I'm definitely not working away.
So you're going to be here?
Yes, absolutely. For the other venture investors in SpaceX, I think they understand the risks. Many of them are also investors in Tesla, and obviously in the car business. That a certain amount of loss of life just occurs every year. It's impossible to avoid. Now, fortunately, at Tesla, we've touch wood, we haven't had any loss of life in any of our cars, but that's certainly something that is impossible to avoid. Just to the law of large numbers, eventually it's likely to occur.
You have a series of rockets: the Falcon 1, the Falcon 9, which has been in orbit, and this capsule, the cargo capsule, the Dragon, which is now configured, as I said, for cargo. What's it going to take for your company to get human beings into space, send them around the world, and then bring them back down safely? How far are you away from that?
Well, actually, if our safety threshold was only equal to that of the shuttle, we could do that this year. In fact, the Dragon spacecraft that we flew in December, if we'd put someone in there with a seat, they would have had a fine journey. However, we think that there needs to be an additional level of safety, which is that there should be a launch escape system, which the shuttle does not have. And so in that launch escape system will take us a few years to develop and verify all the functionality. And so that's why we're expecting to do our first astronaut flight in about 3 years.
Where are you going to get the astronauts?
Well, NASA would be our customer here, so I presume it would be NASA astronauts.
Because they're looking for work now anyway.
Well...
Oh, come on, they are, right?
We actually do have some astronauts at SpaceX that are very experienced and have flown multiple flights and understand both the Russian systems and the space shuttle. And they're participating in the design of the system to make sure that they're comfortable with it. And I think if we're at the point where they say that they would prefer to fly in our vehicle from a safety standpoint over the Soyuz or the space shuttle, then I think we're probably in a good place to begin launching.
One of the ways you've been able to keep down the costs of your operation is that you're not sending people into space. But once you start adding stuff like the launch escape system and various other safety measures, it's going to get more expensive. Are you still going to be competitive?
Yeah, absolutely. I think it'll get a little bit more expensive, but not a lot. I mean, we're estimating it may get 15% more expensive, something like that. So
quantify that for me. I mean, a launch in a Falcon 9 with a Dragon on top is going to cost how much?
Well, if you need to say what's the launch rate per year as well, because there's certain fixed costs that need to be divided over the number of launch rates.
Amortize those costs.
Right. So let's say that the launch rate is 4 per year.
Okay. Which is faster than the shuttle. It should be
No,
pointed at?
that's the shuttle.
Is it about the shuttle's rate? Okay.
Shuttle's about 4 per year.
Okay.
No, but they do have multiple shuttles.
Yeah, that's true.
So, but the max rate, including all the operating shuttles of the last 3 years, was like 4, maybe 5 at most flights a year, between all of them. So, in our case, I think we've said that we would commit to a price of no more than $140 million per flight, and that's carrying 7 people, the same number as the shuttle. So that would be a $20 million per person, and that compares with the Russian prices, which are $63 million a person.
And remind me how much the shuttle costs every time it goes up in the space?
Well, the shuttle's annual budget is about $4 billion, and its flight rate is usually 4. So therefore, the cost per flight is about $1 billion.
Are you ready to take people to space right now?
Well, as I said, if we're willing to accept the same safety level as the shuttle, then yes. But we want to have a higher design safety and have the launch escape system in place. So that would take us about 3 years.
Tell me about the Falcon Heavy.
Sure. So the Falcon Heavy is quite a vehicle. It's really going to be the most powerful vehicle in the world, with more than twice the payload to orbit of the space shuttle. So space shuttle is like around 20 to 23 tons to orbit. Falcon Heavy would be 53 tons. And in fact, it'll be capable of more payload to orbit of any vehicle since or apart from the Saturn V moon rocket.
Payload to orbit, I mean, that's the key thing. That's how much weight
Yeah.
you can get up to orbit
Right.
for a given set of thrust. So.
Right. In fact, 2 Falcon Heavy flights would be equivalent to a Saturn V. So you could send people back to the moon with 2 Falcon Heavy flights.
Should we go back to the moon? Should we go to Mars? Where should this country go in space?
I think that we should be focused on establishing a self-sustaining human civilization on Mars. I think that should be the central focus.
How come?
Well, I guess you could say, well, why is that important? So it goes to the nature of importance itself. How do you decide that anything is important? I think the lens of history is a helpful guide. And if you look at the history on the grandest scale across the 4 billion year history of Earth itself and the evolution of life, and say, what are the biggest milestones in the evolution of life itself? And obviously, it's the advent of single-celled life. There's multicellular life, differentiation into plants and animals. There's migration of life from oceans to land. There's mammals, consciousness. Those are obviously biggies. And I think on that scale would also fit life becoming multiplanetary. I think it would be at least as important as life going from the oceans to land, and arguably more important because at least oceans to land, you could be a gradual process. If it got along too uncomfortable on land, you can hop back in the sea. Whereas, going to another planet you've got to go over hundreds of millions of miles of the vacuum of space through radiation to an environment that's extremely inhospitable, and then you've got to make that environment able to support Earth life. That's really difficult. And for the past 4 billion years, life has been confined to Earth. And now there's this window has opened for the first time in 4 billion years. That's a long time. It's not clear how long that window will be open. But if it is, I hope it's open for a long time, but it may be open for a short time. And so I think the smart move here is to take advantage of this opportunity and make life multiplanetary. And you'll note I said multiplanetary. It's not like some escape from Earth or something like that.
So we're going to stay here and go to Mars as well.
Yeah, exactly. I think that would be cool. I mean, I think there's also sort of an inspirational element to it in that, if you sort of look ahead and see about a future where we're out there exploring the stars and understanding the universe and the kind of things that you see in science fiction books, movies and reading books, that's an exciting future and much more exciting than one where we're just forever confined to Earth until our eventual extinction.
It's an absolutely exciting future, and it's cool to walk in here and see the pictures of the rockets on the walls and go into the warehouse and to the manufacturing center back there and check that stuff out. But there are those who will say, Elon Musk, you can take your money, you can do whatever you want to. But my tax dollars and my government money, we have way too many problems here at home for us to be messing around with Mars or the moon or the space shuttle or any of that jazz, importance or none.
Well, first of all, I should point out that the amount of money we're talking about here is not going to solve any significant earthly problems. The NASA's budget is, all of NASA's budget is like maybe 18 or 19 billion dollars. I mean, that's such a tiny portion of the economy that it wouldn't, if you took all that money and applied it to anything, it would. I mean, you can consider that next to like the annual budget of what it costs us to maintain a war in Afghanistan, or that's like 2% of what we spent bailing out the banks. Okay, that's not a lot. It's not going to solve a lot of problems if you took that money and applied it elsewhere. So I think first of all we need to kind of calibrate the size of funding we're talking about. And then, by the way, SpaceX gets a very tiny portion of NASA's budget. I mean, we get maybe a few $100 million a year of NASA's budget. So we're like maybe 1% of NASA's budget. You could take all that money and it just wouldn't matter applying it elsewhere. But then I'd say, but let's sort of push the argument for why it is important to spend money on space. And I think that there's an inspirational element here that should not be, overlooked. It's if you consider you're going to the moon, and I mean that was a huge expenditure, and obviously only a handful of people went to the moon. But actually, in a sense, we all went to the moon. Vicariously, the whole world sort of was part of that journey, and it was an inspirational thing. And if you think of, what are the great things of the 20th century, that would be one of the things. So, I mean, life cannot just be about solving problems. It can't be about this problem and that problem. There must be inspirational things as well. There must be things that, when you wake up in the morning, you're glad to be alive. And that, I think, is what's one of the things that space can offer.
On the Falcon 9 and its test flights, it's flown successfully twice, which is, a good safety record. Not enough, though, critics will say, for NASA and the government to trust you with going to the space station on resupply missions. How do you prove to people that you can do this and that you're safe?
Well, first of all, you're talking about for cargo missions? Is what you're referring to?
The whole smash. I mean, you got to be safe, whether you're carrying cargo or people.
No, I agree. I was just pointing out that, as far as safety is concerned, for cargo missions, that only applies in the region as you're approaching the space station. And in order to go to the space station, we have to pass a very rigorous set of NASA safety standards and reviews. And it's they really leave no stone unturned. They're very rigorous. So anything we do from a safety standards standpoint has got to pass the same level of rigor that a NASA internal system would do.
So tell me where we are. What is this place?
We're in the SpaceX rocket factory, which is, interestingly, just about 5 minutes away from the LAX airport.
The things you build here are going into space.
Yes. We build giant rockets and spacecraft right here in Hawthorne, California, which is basically LA County. But I think most people just aren't aware of the fact that giant rockets are being built 5 minutes away from where they're catching their plane from Los Angeles.
Do you build everything here, soup to nuts, engines and nose cones and flight software and all that stuff?
We're quite vertically integrated. So yes, we build the engines, the airframe, avionics, and all that sort of stuff, and we integrate that here. We've got a big site in Texas where we test the engines and test the rocket stages, because we can't do that in LA without disturbing people.
And then final assembly takes place at a launch site, I imagine.
We put the stages together at the launch site, but the rocket stages final assembly actually occurs here.
Huh. Interesting.
Yeah. So when the first stage leaves our facility here in Hawthorne, it's this huge stage that's around 100 feet long and at its widest point about 13 feet in diameter. So it just barely fits down the road.
Well, here comes an idiotic question. Do you put it on a boat or a train or a truck? What do you do?
The reason I set the diameter at 12 feet, all of the bits that poke out in some places that go to 13 feet, was that's the the largest road transportable diameter without encountering serious issues where you've got to move power lines and can't get under bridges and that kind of thing.
And it has to go from here to Florida.
It goes from here to Texas to get
Yeah.
test fired, and then it goes to Cape Canaveral, Vandenberg, which is back to California,
Right.
or we're considering establishing a third site as well, which it might be in Texas or somewhere else.
Obviously, you're a guy who is not constrained by his imagination, but did you think that this is what SpaceX was going to be?
You know, I didn't really have any idea what SpaceX was going to be, so it's certainly been a journey of discovery, and I was just completely ignorant in the beginning. So I guess if someone had asked me, do I imagine what a rocket factory would look like this, I suppose I'd imagine something a bit like this, since I made that come into being.
What are the first things you did? You said, okay, I'm going to start a space company. I need a guy who can build me an engine or a rocket designer. I mean, how did you do this?
Yeah, I just started recruiting great engineers in propulsion, structures, avionics, guidance and control, launch operations, that kind of thing.
Yeah, okay, but wait, you can't find that on Craigslist. How did you do it?
I just asked around, and you can kind of triangulate, and I think I've got a pretty good sense for whether somebody's a good engineer or not, and I read a lot of books on rocket technology, and initially I tried to find someone who would be the chief designer of the rocket, and unfortunately the people that were good wouldn't join, and so I had to be the chief designer of the rocket.
It's worth a mention here. Your background is in physics and the hard sciences.
Yeah.
Let's go look at the Dragon capsule real quick, because that to me is kind of the coolest thing. If you look at this thing, and if you've been in the Air and Space Museum in Washington, and you've seen the Apollo 11 capsule that's there, there's a certain familiarity, right? It's got the basic shape of a spacecraft and of a capsule that's going to keep people in it.
Yeah.
When you set about designing this thing, I mean, obviously, rocketry comes from a certain heritage, and there's only so many ways to reinvent the wheel, if you will.
Right. Yeah, a reel has to be
Wheel,
round,
rocket,
or it's not
whatever.
going to roll very well.
Yeah.
Yes, when it comes to reentry vehicles, there's just two basic approaches. One is with wings or without wings. You
Right.
know, and I think wings are not a great idea.
Yeah, and we've done both, right?
Yes.
We've done the Apollo capsule without wings, and we've
Yes.
done the space shuttle with.
Yes, and it's worth noting that, Wernher von Braun, who was sort of one of the key architects of the Apollo program, arguably the best rocket designer in history, was well aware of wings. It's not as though that was a foreign concept, and you have to say, well, why didn't he and Max Faget and the other ones, why didn't they add wings? Maybe they weren't smart enough. I don't think that was the reason.
So clearly the non-wing approach is where we go. It's got the rounded bottom with the heat shield. It's vaguely conical.
Yeah, there's a big advantage to a capsule or sort of gumdrop, or basically an approach without wings, which is you can have something which is naturally stable with the primary heat shield down.
Right.
So even if you have a systems failure that's quite serious, you're still safe. And when you're coming in, when you're re-entering the atmosphere, you're coming in like a meteor. I mean, you're a fireball from hell. If you don't have that heat shield, you get vaporized. So having that main heat shield pointing in the right direction is real important. Now, in this case, the space shuttle, because it's got wings, you've got to control it to a precise angle of attack. If anything happens with your control systems or the body flaps or anything, you're gone. Plus, wings force a heat concentration at the leading edge, and so you're really limited in the materials that you can use in leading edge. In fact, you cannot use there is no material that will work for re-entering at velocities greater than Earth orbit velocities with a wing. So in other words, if you want to do a moon, Mars, you have to use a capsule design, because the wing leading edge creates such a heat concentration that there's no material that can withstand it. And if you look at the Russian Soyuz, where they've had numerous problems, the Russian electronics are not the most reliable, and they've had many issues on the Russian Soyuz, and yet they haven't had a death since the 70s. And that's because the capsule design as an architecture is so much more robust. That's really the reason that gone that direction. Now, I should point out something important, though. People may think that because it doesn't have any wings, it's coming in uncontrolled.
Oh, yeah.
Which it's natural to assume. You might think, oh, yeah, that's the case. But actually, that's not the case. We have onboard thrusters that control the reentry and can actually guide that reentry to a very precise landing point. And in fact, the only dispersion error on the landing is the wind drift from the parachutes. Otherwise, we could land it on a helipad. And for the next generation of Dragon, we're actually going to step up the technology to a new level, which is propulsive landing. So we'll have the parachutes there as a backup. So you can always pull the parachutes if there's a system malfunction, and you'll be able to manually pull them. So even if the electronics have gone all to hell and you got holes in the craft and it's barely hanging together, you can still pull the parachutes and be safe. But in a normal case, it'll actually be able to land propulsively on its engines with little landing legs that pop out.
Wow.
Just like they landed on the moon.
Right. This one we're looking at. This one's going to space, right? It's got a heat shield with a big sign on it that says "Do not touch," and I mean all this.
Yes.
Stuff. Right? Of course, there's guys climbing all over that thing. But
you're looking at the craft that is going to go to the space station. So that's got all the systems on board, the guidance and navigation control systems that are required to do an automated rendezvous and berthing with the space station. So this is coming in as a robotic spaceship. It's basically it's kind of wild when you think about it. Like, we're making a spaceship that's docking with a space station. I mean, how crazy is that? And it's doing so automatically. Now, it's going to stop at various points and wait for confirmation. So it's not going to go barreling in there. So it's going to get, to within a few miles, and then wait. We'll look at all the data and make sure everything's good, and then it'll get asked for permission to go to the next step, and then gradually it'll get closer and closer to the space station. So that's one of the ways that we can ensure that everything's going to be okay. But it's got a pretty cool navigation suite. It's basically got something called LiDAR, which is laser radar. So it scans the space station with a laser, figures out the relative orientation, distance, and everything, plots an approach vector, and then goes in there, and it can dynamically adjust to whatever the orientation is of the space station and where the docking ports are and everything.
So this is a little off the wall question, but what is it about you and advanced modes of transportation between Tesla and this company?
Well, in the case of Tesla, Tesla's about helping solve the sustainable transport problem. I think in terms of terrestrial technology problems, I think the biggest single problem that humanity faces in the 21st century is sustainable energy, and that's both sustainable production and consumption of energy. And so Tesla is about helping solve the sustainable consumption of energy. And of course, one of those, it's a transport thing. But it's not as though I have like a huge transport, because I've also got Solar City, which is solar power. So it's really from the context of, what are important problems that I can potentially help solve that would make a difference to the world.
Elon Musk, thank you so much.
Thanks for having me.
Elon Musk, good to have you with us.
Thanks for having me.
So there's a clear answer to this question, and then there's the existential answer to this question. What are you guys building out there?
We build rockets and spacecraft.
Yeah, now give me the existential answer.
Well, what we are aspiring to do is to help make humanity a true spacefaring civilization and ultimately become a multi-planet species.
This is going to sound
Is that
pejorative.
existential enough for you?
That's quite existential. I like that. But here's the thing. You're doing it on the cheap. I mean, that's, there's an award out there in the lobby that says, Elon Musk, you get the award for economic spaceflight.
Yes. Well, the fundamental problem with rockets is that they are far too expensive. And so that's the thing that has to be improved dramatically by ultimately, I think, at least a factor of 100.
That's a pretty good, chunk of change you're taking out of the cost of this thing.
Yes, absolutely.
How do you do that?
In order to achieve that level of improvement, the great breakthrough that is needed is a fully and rapidly reusable rocket. No one has ever succeeded in building this. In fact, no one has ever succeeded in building a fully reusable rocket of any kind, at least that's capable of getting to orbit. This is where the space